So how do we prove this? So to prove it, we're going to work Euler by Euler factor. So let's look at the bad Euler factors first. So the Hecke character, right, like I told you that at bad ideals, you should just pretend that it's 0. So on the Hecke side of the equation, have like 1 over 1 minus psi of p to the minus s times 1 over 1 minus psi bar of p to the minus s. But I told you to pretend that it's 0, so this is just 1. Question?
Yeah. So like, what about ramified primes and f? Do they also be
Primes ramifying in f over k. So what you're asking about.
Yeah, because you talked about it for Frobenius.
Right, but this is a Frobenius of a prime of f, not a prime of k. It's a Frobenius of p with a long tail. It's a prime of f.
It's
Right?
different. It's the lift of the geometric.
Yeah. Oh, so those two different meanings.
It's not a Galois. It's not a Galois element.
Right. There is a Galois.
Conjugacy class.
Yeah. Thank you. So the element in K that's a lift of the geometric endomorphism of the curve over the finite field named Frobenius is an element of K, and that's fine. That has nothing to do with ramification of Galois.
P's power amount.
And then I'm also talking about
different.
Frobenius of frac P with a long tail on the Tate module.
Right.
But that's okay because I'm only looking at the action on the inertial invariants of the Tate module, which are just defined so that there's no problem with what you've just said. There is a problem that I have to choose a Frobenius, but they're all conjugate and I'm computing some characteristic polynomial, and so it'll be the same. Okay, but I'm just looking at the bad Euler factors right now, and definitely from the Hecke character side I get 1, right? This has nothing to do with geometry. This is just, we've said if I put a prime into a Hecke character that's not prime to the conductor, I evaluate it like 0. This is 1 over 1 times 1 over 1, that's 1, right? So that means on the elliptic curve side I should get 1. And that's true. So the local factor p, these guys should have long tails. The local factor p also is equal to 1 because CM elliptic curves have potentially good reduction, which means they have additive reduction. So that takes care of the bad factors. So I got to show you the good factors are the same. So the fact that the good factors are the same sort of follows from FOIL. So if so I'm just going to show I'm just going to FOIL out those denominators. So this is the reciprocal of that. And these should all be p's with long tails. Right. This is going to be 1 plus psi of p plus psi bar of p times the norm of p to the minus s plus psi of p times psi bar of p times the norm of p to the minus s. Sorry, minus 2s. Okay. Well, this is equal to 1 plus, so remember I said when you have an endomorphism, you can compute its degree and its trace using traces from k down to q. So this is the same thing as the trace from k down to q of psi of p plus the determinant, or the norm, right? Did I make a sign error? Yeah, right. this should be minus. I just spoiled it, right? Good, because the characteristic polynomial we want a minus in front of the trace. Great. Plus, right, so this is the determinant from k down to q of psi of p times norm p to the minus s. Okay. But what is this, right? So when you're computing a characteristic polynomial on a two-dimensional vector space, right, it's always the case that the coefficient of the square is the determinant of the matrix and the coefficient of the linear term is the trace. So this is just the characteristic polynomial of psi acting on L torsion or the elliptic tape module. But now the result follows, essentially I'm out of time, but it follows from the fact that psi is a lift of this geometric map named Frobenius, but the reduction of the map named Frobenius in Galois theory is also the map that on coordinates raises coordinates back to the q, y to the q, so it's the same characteristic polynomial that defines the L factors. And I'm done.
Any questions for Hunter?
Yeah, so why is over a number of fields can you not get a determinant out?
That's a good question. So actually, over any field of characteristic 0, the endomorphism range in the elliptic curve has to be commutative. I'm trying to think if I want to prove that off the top of my head. I might just not know it. Let's see. I can look it up though. I have 4 books here.
We can look at it.
No, it's fine.
Easy way.
I want to know.
Oh, I'm gonna